Hey, today I would like to demonstrate how to generate PDF using latest Chrome with Puppeteer on AWS Lambda inside a Docker container. This is proven to work on Amazon Linux 2023, verified in June 2025, simple and easy. So what we are going to do is to open this page, what is Puppeteer, in AWS Lambda using headless Chrome, print it to PDF, and then upload to AWS S3, and then download it to local to verify it is working. So let's get started. First, let's see the result. I have already deployed the whole application to AWS Cloud so that we can directly invoke it. As we can see, the log shows the progress of how it works, and it gives us a comment at the end to download the generated PDF from S3 to local. After downloaded, we can open it, and here is a printed version of what is Puppeteer. Then let's look at the implementation details. I am using AWS Serverless Application Model, SAM for short, to make this minimum example. This is basically the auto-generated template from the Node.js 22 Hello World example with some modification. So what I have done for this template is I have modified the default timeout for each function from 3 seconds to 120 seconds. We will generally don't need that much, but 2 minutes should be good enough. Then this hello world function, I increase the memory to 4 gig. Again, it's actually not going to use that much. It usually, in this minimum example, it will use about 600 megabytes, but the higher memory size the Lambda is, the faster it will run generally. Then I'm going to attach the policy Amazon S3 full access to it. This is not a good practice in general, like attach the full access, but for this minimum example setup, quick and easy, let's just attach that. The metadata part, this is basically auto-generated by the template. I'm not going to touch it. S3 bucket, as mentioned before, like I have to save the generated PDF somewhere in order to get that. Otherwise, the generated PDF remains in the temporary file system on Lambda runtime. There's no way to access it. Then let's look at the Dockerfile that we're going to use to generate the image to be deployed on Lambda runtime. First of all, we need to be based on a base image from AWS Lambda, so we choose Node.js 22. Saying that, one of the most important things to be noted here is we have this -x 86_64. This is to make sure that the image we are based on is exactly the same one that we use for our Lambda runtime, and it should not be depend on the host machine's CPU architecture. Say for example, I am using the Apple Mac OS, and my CPU is M4 Pro, which is an Apple Silicon ARM64 based architecture. It's not this x86-64 architecture that we are going to use for the Lambda runtime. If I don't add this one, it will actually going to use the ARM one, not the 86 one. So this is necessary to be based on a very specific CPU architecture to match the architecture we are going to use on Lambda runtime. So this needs to be emphasized. Then we need to install the Chrome. So as we can see, this line is actually we are using the Puppeteer, the official Puppeteer tool, to install the Chrome binary with a version. So this version is basically the latest version as of today. As we can see, this is the latest Puppeteer, latest version that Chrome it's supported, and this is a Chrome for testing availability page, and it says this version is the latest stable. So basically, we are using this version. So this is the binary provided officially from Google, and we are installing it to /opt, so that we are going to know that exact path where to find the Chrome executable, the Chrome binary, when we need to use it in Puppeteer. However, this line is not enough, because the binaries provided by Google for Chrome, for Linux, is not including everything it needs to run. So we actually need to include a bunch of other dependencies to support this installation. Luckily, we don't need to spend much time to figure out what's missing. There is a Docker Selenium Lambda project actually showcase what are the missing dependencies, so we can just copy from there and install it here. By the way, I have asked ChatGPT about what all this library actually are, and here is the table of that. Feel free to read it or ask it by yourself or do more researches. I have attached it to my original blog. So after this two-step, Chrome has been installed, should be successfully. And then we are going to copy our code from the host machine to inside the Docker image. So basically, we copy the package.json, package log.json, and run npm install. For the application code file, we actually only have two files. One is app.mjs, which is the entry point of the script, and another Puppeteer RC CJS file to specify some extra configuration for Puppeteer. And this is the generated code by the template, but this is required to be used with Lambda runtime. So this is a Dockerfile. Finally, let's look at the Lambda code that we are going to run on the runtime. So first, we need to ensure some folder exists for the runtime to write content to. So the first one is the Puppeteer cache folder. So this is configured here in the Puppeteer RCCJS. So we give it a writable folder from /tmp. So this is a temporary folder that Lambda has write access to. The default ones, if we don't configure it, the default ones is under a user folder, which is not really writable. You will get an error if you don't override this configuration. So let's override this cache path and then ensure the folder exists. And ensure the folder exists would be quite easy as well. So we use this fs extra npm package to just ensure that directory exists synchronously. Similarly, I want to generate the file, PDF files on the /tmp/pdf. So let's make sure that this folder is also exists and writable. Then the major part, we could then launch the browser. So this Puppeteer launch needs a long list of options configuration. So we want to see the headless true, so we don't need any UI to be run on the Lambda runtime. The dump IO to be false. This is already the default to be false, but in case if you need to debug the whole progress. If anything not working, so on and so forth. Turn it to be true would actually helpful. Timeout 0, it's just to not let the launch browser timeout. Executable path. This is what we mentioned in the Dockerfile section, that we install exactly version of the Chrome to the exact place that we can find and assign here. So /opt/Chrome. This is the version and the folder and the /Chrome. This is the executable of the Chrome binary. And then to launch the Chrome, there are a few args that we need to pass in. Again, very luckily, we have this Docker Selenium Lambda as our pioneer, so we just need to copy their args. So headless new, no sandbox, a bunch of those things, and there are a few that data dir, directory data path, disk cache dir. These things we all make sure that they are running on /tmp, so that this Chrome session can actually write the data into there. Similarly, there is a ChatGPT version explaining what are the args actually doing. Feel free to check it out. Then after this browser being launched, we can load the content. So basically just create a new page and let it go to a URL. Wait until the network all finished. Then generate the PDF by calling page.pdf. Give it a file path. Let's emphasize it again, like this file path needs to be /tmp something. So only under /tmp the Lambda runtime can write file to. Otherwise, you will get non-access errors, so on and so forth. And then after we generate the PDF, we could get some meta information, like what the file size of it, and print it out. Then close the browser. After that, we have to upload the file to somewhere. Say I choose S3 to actually store or persist this file from the /tmp to a place that we can actually reach to. Otherwise, if it remains on /tmp, as a user or programmer, I'm not able to access that. That's only accessible by the Lambda runtime. So I will just read the file content of this file and then send the content to S3 bucket using this put object command. Then the console log will show what is the exact path it uploaded to S3, and then another log to help us to directly copy the command we need to get the file from S3 to local, as we showed in the beginning of the video, that we can directly copy and run so that we can get the S3, we can get the PDF from S3 to local. So next thing I would like to show is to build and deploy it to AWS Cloud and then invoke it. But since I already deployed the current version, if I directly build and deploy, there will be nothing changed to be deployed. So we will actually change to print another page instead. So we are going to print this installation page rather than what is Puppeteer page. So this will trigger an update. So we'll just go SAM build and SAM deploy and then wait. So now it is being deployed. We just need to run the SAM remote invoke hello world function to actually run that logic on the runtime. So this is a successful run, and let's download the PDF and see the installation page is now being printed out rather than the original what is Puppeteer page. Great success. So we have just worked through the code example to set up a container-based Lambda function for PDF generation using the latest version of the official Chrome binary and Puppeteer built on top of the Amazon Linux 2023 and Node.js 22 Docker image. This should be a solid starting point for building your own PDF generation service using AWS Lambda without the limitations of code package size or relying on community-built Chrome binaries. Thanks for watching.